linear motion, two moving objects moving in opposite directions. So in these questions, we're going to have two objects passing a given point and then moving away from each other. So we're going to have here two cars moving at speed in opposite directions past a traffic light. The first one is travelling at a speed of 10 metres per second with an acceleration of 1 metre per second squared. The other is travelling with a speed of 20 metres per second and a deceleration of 5 metres per second squared. How far apart will they be when the second car comes to rest? And at what time were they half this distance apart? So if they're travelling towards each other, reach the traffic light and then set off from the traffic light, they have then passed each other and are moving away from each other. So if I say car A and car B, then at a particular point in time, both will have travelled a given distance. So in other words, when car B comes to a rest, how far will they be apart? Well, basically the distance between them at that point will be S1 plus S2 at that point in time. So we need to know at what time does the second car come to rest, and then we can work out S1 and S2. So the time taken for B to come to rest. Well, what do we know about car B? Well, we know that its initial velocity is 20 metres per second. We know that the acceleration is negative because it's decelerating. It's coming to a stop. And the final velocity is 0 metres per second. So if we use v is equal to u plus at, we can see how long it takes to come to a stop. So we have 5t equals 20, and therefore t equals 4 seconds. So it takes car B 4 seconds to stop. So when it stops, so at this time, we know that t is equal to 4 seconds, which means we need to know, well, where is car A at t equals 4 seconds? And then we can combine S1 and S2 to see how far apart they will be. So again, we say car A and work out its distance travelled. Well, for car A, we can say U is 10, A is 1, and we know the time that we're looking at specifically is 4 seconds. So therefore we can find the distance travelled using S equals UT plus a half AT squared. So S1 will equal 10 times 4 plus a half times A times 4 squared. So that's going to be 40 plus 8, which is 48 metres. And then if we do the same for car B, well, for car B, the initial velocity is 20. Its acceleration is minus 5 metres per second squared because it's slowing down. And the time we're looking at is 4 seconds, and then S2 we're trying to find. So we say ST2 is equal to U times T plus a half A times T squared. So we have 20 times 4 is 40, and then we're going to have 16 times a half, which is 8 times minus 5, and therefore that gives us 40 metres. And therefore we can say that the distance between them is going to be the sum of their distances travelled after 4 seconds. So 48 plus 40 means they are going to be 88 metres apart. Okay, so when are they half the distance apart? So half the distance apart, is going to equal 44 meters. So again, we would say d is equal to s1 plus s2, but we're looking for the time that they are half this distance apart. So I put in 44 is equal to s1. Well, s1 is going to be 10t plus a half at squared plus s2. Well, s2 is 20t plus a half at squared. So that gives me 10t plus a half t squared plus 20t minus 5 over 2 t squared. And if I multiply across by 2 there, that gives me 88 is equal to 20t plus t squared plus 40t minus 5t squared. So simplifying that and bringing everything to the left-hand side there gives me 4t squared minus 60t plus 88 equals 0. And if I divide across there by 4, I get t squared minus 15t plus 22 equals 0. Okay, so we can use our minus b formula here to solve for our times. So a is 1, b is minus 15, and c is 22. So t is going to equal minus b plus or minus b squared minus 4ac over 2a and then the square root. So subbing in our values there, we end up with t is equal to minus 15 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 15 plus or minus the square root of 137 divided by 2, which then gives me 2 times. So we get t1 is equal to 1.65 seconds, or t2 is equal to 13.35 seconds. But because the distance is half the distance travelled, and the time taken to travel the 88 meters was 4 seconds, well then clearly t2 is greater than 4 seconds, so therefore we cannot use that. So therefore the time taken for them to be half the distance apart must be the time that is less than 4 seconds, which is 1.65 seconds. Okay, so this is not a common question in the Leave Insert. It has never come up. So there's only one question in the book that you're going to do for me on this, and that's page 31, question 17. Okay, so we're going to do the next type, which is the last type in this chapter, which is the nth second. So the last topic in this chapter is our nth second. And the question we're going to look at as our example is page 35 in our textbooks in Murphy. And what's important to note is when we're doing sequencing series in 6th year in maths, we're going to come across what's known as our nth term. So the nth term is often written as t of n in a sequence where there's a pattern. And for us to find our nth term, the n that we'll be referring to in this section is the nth second. So t would equal term and n equals the position. So in this one here we're told a particle is travelling with an initial speed of u and a uniform acceleration of a, and we have to show that the distance travelled during the nth second is given by u plus an minus a half a. So what that basically means is that if we look at the distance travelling, s, and we want to look for the distance travelled after, say, 10 seconds, and then we look at the distance travelled after 9 seconds, that would be 1 second less. Then if I get the difference between those, so the distance travelled after 10 seconds, so 10 seconds, we'd find the distance travelled for 10 seconds, and then we'd find the distance travelled for 9 seconds. Then during the 10th second, this would be the distance that would be travelled. So in other words, we get the difference between them, and that gives us the distance travelled during the nth second. Okay, so to prove this is going to equal u plus a of n minus a half of a, then what we want to do is find how far has it gone after n seconds. So say it was 10, we'd work out for 10 using u plus a half at squared. So we know the initial velocity is u. We're not given any units there actually. I'll just take away my units. We know that the acceleration is given by a. The time that it's travelling for is going to be n seconds. And we're going to find the distance travelled during that time. So using s equals ut plus a half at squared, then we would say the distance travelled during those n seconds is ut plus a half, sorry, not ut, un, plus a half a n squared. Now, if I look at how far has it gone in 1 second less than that time, so n minus 1 seconds, then again, the initial velocity is still the same, the acceleration is still the same, but the time that we're looking at is just 1 second less. So we'd be looking at how far has it gone in that time. So if we sub in, we have s of n minus 1 is equal to u times n minus 1 plus a half a times n minus 1 squared. So simplifying that would be un minus u plus a half a times n squared minus 2n plus 1. So simplifying that gives me un minus u plus a half a n squared minus an plus a half a. So say, for instance, this is the time taken for the distance travelled after 10 seconds, and if this is the distance travelled after 9 seconds, then the distance travelled during the 10th second would be the difference between those two. So we're then going to say, well, s during the nth second is the difference between the two. So we would have un plus a half an squared minus un minus u plus a half an squared minus an plus a half a. And getting rid of those brackets then, we have un plus a half an squared minus un plus u minus a half an squared plus an minus a half a. So we can see we have un minus un. We have a half an squared minus a half an squared. And that leaves me then with u plus an minus a half a. And that's what they wanted us to show. Okay, so the next part of the question, so if we go back, says if the particle is travelling 17 metres in the second of motion and 47 metres in the 7th second of motion, how far will it go in the 10th second of motion and in the nth second of motion? So what that basically means is that in the in the second, the distance travelled is 17 metres. And in the 7th second, the distance travelled is 47 metres. So we can use what we've just found. So in other words, during the nth second, we know that it's u plus an minus a half a. And if we sub in, well, what does that give us? Well, for the second, we have u plus a, and n is going to be 2, minus a half a, and that's equal to 17. So if I simplify that, that's going to be 2u plus 3a is equal to 34. So multiplying across by 2 there. So that gives me one equation in terms of u and a. And there for the 7th second, if we do the same, well, it's going to be u plus a times n. So n is going to be 7 for the 7th second, minus a half a, and that is going to be equal to 47. So if I multiply across by 2 and simplify there, we're going to end up with 2u plus 13a is equal to 94. So now we have two equations in terms of u and a. So this is going to allow us to find the initial velocity and the acceleration. So in other words, we have simultaneous equations here. So I'm going to multiply the second one there by minus 1. And that gives me 2u plus 3a equals 34. Minus 2u minus 13a is equal to minus 94. So that's gone. And that leaves us with minus 10a is equal to minus 60. And therefore the acceleration is 6 meters per second squared. And now I can sub in a into the first equation. And therefore we have 2u plus 3 times a is equal to 34. So 2u plus 18 was 34. So 2u is equal to 16, and therefore u is equal to 8 meters per second. So what that basically means then is that we know what u and a is. So we can say for the 10th second, u is 8, a is 6, n is 10, minus a half times a is 6. So during the 10th second, we end up with 8 plus 60 minus 3. So it's 65 meters. And during the nth second, well, that would be 8 plus 6n minus a half times 6, which is 8 and 3, so 8 minus 3 I should say, which is 5 plus 6n. Okay, so then C says during which 2 consecutive seconds will it cover 256 meters? So in other words, during the nth second, it's going to travel 256 meters. But we know that during the nth second, that would be s of n minus 1. So therefore, I know that s of n is 5 plus 6n. So s of n minus 1 would be 5 plus 6 times n minus 1, which would be 5 plus 6n minus 6. So that would be 6n minus 1. And therefore we would say s of n, which is 5 plus 6n, minus s of n minus 1, which is 6n minus 1, is equal to 256. And therefore that's 5 plus 6n minus 6n plus 1 equals 256. And therefore we have, the 256 is during which 2 consecutive seconds. I've just read the question wrong there. That's my fault. Apologies. So what we have is the sum of those two is going to be equal to 256. So the distance travelled during 1 second, so the nth second, and the distance travelled during the previous second, if we add those two together, will be 256. So during the 2 consecutive seconds. So we have S of n is 5 plus 6n, as we've just said, and S of n minus 1, we saw there was 6 of n minus 1. So by looking at the distance travelled during the nth second and during the n minus 1th second, then by combining those we get 256. Then that's 5 plus 6n plus 6n minus 1 equals 256. So we have 12n plus 4 is equal to 256, and 12n is equal to 252, which means that n is equal to 21. So in other words, the 21st second and the previous one, so the 21st and the 20th second, be n minus 1. So basically what that means is that the particle travels 256 meters during the 20th and the 21st second. Okay, so what I'm going to get you to do then is, so it's the 2015 higher level question 1A. So particle starts from rest, moves with constant acceleration. The particle travels 39 meters in the 7th second. Find the distance travelled in the 10th second.